Okay, so here we have a problem. If this is question 8 in section 4.2. Evaluate the following expression without using a calculator. So what we do here is we want to recognize this has a very special form right here. And if I go down and I hit view an example, they'll just give us this formula right here. We can see the formula. So according to the inverse property of logarithms, so you can look that up in the book if you want to look into it further. The inverse property of logarithms says that for b greater than 0 and b not equal to 1, if we have b to the log base b of x, this equals x. Now this might seem like kind of a confusing formula at first, but what you want to recognize is that we learned that an exponential base b and a logarithm base b are inverses of each other. And remember, when you compose inverses, then you are supposed to get x back, right? You get whatever your input was into that composition, you get that same thing back. So it makes sense here. We can see there's an exponential function because we have a base b being raised to some power, but the power it's being raised to is a logarithm. It's inverse. So the logarithm and the exponential function actually undo each other in this case, and you're just left with x. You get whatever you started with. So for us, that means that the base 7 exponential composed with the base 7 logarithm are inverse functions, and they cancel each other out, leaving us with 4. And there we go. Okay, so it's just that special form, right? And if you need, you can pull up the ebook and just read the little section about that. And then whenever you recognize that form where it's either an exponential raised to a logarithm or a logarithm raised to the exponential, as long as they're the same base, they just cancel each other out. And in fact, we make use of that in coming sections when we solve equations. Okay.